Okay guys, so today we are going to be reviewing for your test. So this is the study guide. So at the top of our study guide, I wrote all the different vocabulary terms that could show up on your test that mean slope. So constant rate of change means slope, constant of proportionality means slope, direct variation means slope, as well as unit rate. So anytime you guys see those words on your study guide that we'll be talking about today or on your test on Tuesday, all of those words mean slope, okay? So number one, what's the constant rate of change of the table below? Well, there's that word right there, constant rate of change. Constant rate of change means that we're trying to find the slope of the table. And there's a couple different ways that you guys can find the slope. One way is to find your change in y's over your change in x's. And remember, this hours would be represented as your x and miles would be written as your y. So if you wanted to find the slope, if we went from 70 to 140, notice how we just increased by 70. If we went from 140 to 210, once again we increased by 70. And then if we go from 210 to 280, once again we increase by 70. So notice how all of our change in y's were the same. So the change in y for our slope would be 70 over, and then it also depends on our change in x's. So when we go from 2 to 4, notice how we add 2. If we go from 4 to 6, we add 2. And then if we go from 6 to 8, you also add 2. So then our change in x's is 2. So can we reduce 70 over 2? Yes, we can. If you guys were to take 70 divided by 2 in your calculator, you would get 35. So our slope, or constant rate of change, would be 35 miles per hour, which is D. Okay. The other way that you guys could have found slope was by using the y over x as your ratio. So you could have just wrote 70 over 2, which once again reduces to 35. You could have done 140 over 4, which would reduce to 35. 210 over 6, which reduced to 35. And then 280 over 8, which would reduce to 35 as well. So a couple different ways to do that. So the change in y's over the change in x's is how I taught my class, but you could also look at your ratios just like we talked about with proportions, okay? All right, number 2, what is the slope of the line? So remember, you need 2 points to find slope of a line, and as long as they cross at intersections, you can use any 2 points. So let's say I use 0, 0, and 2, 1. Remember, you always start the point furthest to the left, so I'm going to start here. And remember, to find the slope of a line, you are using rise over run. So you always want to rise before you run. So notice how if I'm trying to get from this point to this point, I rise up 1 and I run 2. So if I rise up 1 and I run 2, that means that my slope is 1 over 2, or in other words, F. All right, next one. Dawson rakes leaves in his neighborhood. The equation y equals 10x represents the amount of money he earns. What is the constant of proportionality? So again, here's one of those words that mean what I talked about up here, slope. And remember, our slope equation, or we talked about it with direct variation, is y equals mx. Or if we were talking about direct variation, it would be the y equals kx. And the number, or the letter that's attached to our variable x here, is represented by slope. So if you notice our equation y equals 10x, remember I just said the slope is always attached with the variable x, and if they want to know what's the constant of proportionality, they're asking what's the slope? Well, it's the only number that's in the equation, and that's 10, because the number is always attached with the x for our slope, and y equals mx or y equals kx for your equation. So what is the constant of proportionality? It is 10. Number 4, what's the solution to the proportion? So remember, this is the cross products. So you multiply your diagonals. So if I were to multiply 3 times y, that gives me 3y. If I multiply my other diagonal, if I take 16 times 9, That would give me 144. And then your last step is we still need to solve for y, so you always divide by the number attached with the y. So we divide by 3 on both sides, and 144 divided by 3 gives us an answer of 48. So that should be G. All right, number 5, which size can of green beans shown in the table has the lowest unit price? So unit price, we're talking about unit rates. So remember, with unit rates, your denominator has to be 1. And to solve unit rates, all that you guys have to do is divide, okay? So we have ounces and cost here. Ounces is represented by our x variables, and cost is represented by our y variables. So when we find the unit price, you always want to take your y variable divided by your x variable. So in this case, if I'm trying to find the unit price, I need to take 89 cents divided by 6, $1.04 divided by 8, $1.69 divided by 10, and $4.79 divided by 32. And remember, when you're finding the unit price, this is going to tell you which one's the cheapest per ounce. So that's the reason why we need to change these all into unit price, so that we can find out which one is the cheapest per ounce. So again, take your cost divided by the ounce. So our first one is 89 cents divided by 6, and I have my calculator here. So 89 cents divided by 6 gives me 0.1483 repeating, but since this is dealing with money, you always round to the nearest cent. So the hundredths place, look at the number behind it. If it's 5 or greater, then you round this up. So this will turn into 15 cents for 1 ounce. Then we move on to our next one. So we have $1.04 for 8 ounces. So once again, to find the unit rate, you just divide. So take 104 divided by 8, and that gives us 13 cents for 1 ounce. Next one's $1.69 divided by 10. So $1.69 divided by 10. Again, you always want to round to the nearest cent. So notice if I look at the number behind it, it is 5 or greater, so this will turn into 17 cents per ounce. And the last one, $4.79 for 32 ounces. So again, to find the unit rate, you just divide. So $4.79 divided by 32 gives us 0.149, which if I round to the nearest hundredths will be 15 cents for an ounce. So looking at our unit rates, we have 15 cents for 1 ounce for the first can, 13 cents or 1 ounce for 13 cents for the second can. 1 ounce is 17 cents for the third can, and the fourth can is 1 ounce for 15 cents. So you just need to figure out which one is the cheapest, and hopefully you guys are realizing that our second can is the cheapest since it's only 13 cents per ounce compared to our other ones. So this was the 8 ounce can, so that means that B will be our cheapest unit rate. Alright, and the last one on the front page, if it takes the Jones family 2 days to travel 1,240 miles, how many days will it take them to travel 2,480 miles? So anytime that you guys see 3 numbers in a problem like this, you guys should always think to set up a proportion, because when you set up a proportion, you always have 3 numbers in your proportion and 1 variable which you're trying to find. And that's what we have here. We have 3 numbers and we're trying to find how many days will it take them to travel this many miles, okay? So remember, with proportions, you always have to align everything up. So notice how our 2 variables are talking about days and miles. So let's say I want to put days in the numerator and miles in the denominator. So you want to make sure that all of your numbers up at the top of your proportions are talking about days, and your numbers at the bottom are talking about miles. And it also has to align vertically as well. So this says if it takes the Jones families 2 days to travel 1,240 miles. That means that that needs to go in my first proportion here. So if I had days on top, 2 days in 1,240 miles, so miles went on bottom, and we're trying to figure out how many days will it take them to travel 2,480 miles. So since this number is talking about miles, in my proportion, I need to make sure that it all lines up. So my 2,480 will go on bottom, and since we're trying to figure out the number of days, I'm going to put my X up at the top. Okay. After you guys set up your proportion, you can cross multiply. So if I take 1,240 times X, that gives me 1,240X. And then multiply your other diagonals. So if I were to take 2,480 times 2, that gives me 4,960. And then to get X by itself, remember to always divide by the number attached to it. So I will divide by 1,240 on both sides of my equal sign. My 1,240s will cancel because that equals 1. So I'm now left with X equals 4,960 divided by 1,240 gives me an answer of 4 days. So this would be G. Again, you guys know that you can pause the video at any time to get caught up. I'm just going to keep moving on. So this next one, the graph shows the amount of money Amy earns each hour she works. Choose all the statements about the graph that are true. So the first one says the graph shows a non-proportional relationship. Well, remember, for a graph to be proportional, it has to have 2 requirements. The first one is it has to go through the origin, and if you guys notice, it does go through the origin, so 0, 0. And the second requirement is it has to be a straight line, or in other words, it has to have a constant rate of change. So if you guys notice, this is a straight line. So since it does go through the origin and it has a straight line, this means that this graph is proportional. So it's not F, because that would be non-proportional. G says the graph shows a proportional relationship, and we just talked about how it was, because it went through the origin and it was a straight line. The unit rate is 38 cents for 1 hour. So remember, unit rate means slope. So if I look at my slope here, so it says the slope is for 1 hour 38 cents. So if I look at 1 hour, this says that this is about or maybe $6-7 an hour. So it's definitely not 38 cents per hour. So that's not it. And then I says the line is straight, which that is true. So it should have been G and I for that one. All right, number 8, the table shows the cost for ordering a certain number of tacos. What is the value of X if the cost is proportional to the number of tacos ordered? So there's a couple of different ways that you guys could do this. One way is to set up a proportion, and it even tells you that it is proportional. So you could set up a proportion using any of these 3 numbers here, and then just making sure your last fraction in the proportion contains the X. So let's say I used the 2 and 260 and the 6 over X. I can just set that up as a proportion since they already aligned up my variables for me. So if I had 2 over 260 equals 6 over X, this could give me my value of X of how much it's going to cost for 6 tacos. So again, just cross multiply. 2 times X is 2X. 260 times 6 would give me $15.60. And then your last step to get X by itself is to divide by 2, and you would get an answer of $7.80. The other way to do this, but you guys would just have to be careful, is to find out what the unit rate is. So remember, to find the unit rate, you just take the ratio of Y over X. So if you were to take the ratio Y over X, that would be 260 divided by 2. That gives you $1.30. and you could have done that for all of these. So 390 divided by 3 is $1.30, and 520 divided by 4 is $1.30. So if you know that the unit rate is $1.30, which means that one taco equals $1.30, to figure out how much 6 tacos cost, just take $1.30 times 6, and notice how you get that $7.80 again. Okay, so again, a couple different ways to do it. Just figure out what way works best for you and easier for you to remember, and then that can give you your value of x. All right, moving on to 9 and 10 here. So we are to solve the following problems using a proportion. So remember, proportions are two ratios that equal each other, and then we're trying to find a missing variable within the proportion. So if it takes 15 gallons of gas to drive 330 miles, how many miles can be driven using 20 gallons of gas? So again, when you set up your proportion, you always want to make sure that everything is aligned horizontally and vertically. So looking at my two variables that I have gallons of gas as well as miles. So if I put my gallons on my numerator, I need to make sure that my numbers in the numerator are talking about gallons of gas, and then the numbers in the denominator will be talking about the miles. So if it takes 15 gallons of gas to drive 330 miles, that will be my first set of ratios that I have. So 15 gallons, if I have gallons in my numerator, I need to make sure that 15 goes in the numerator, and then miles is in my denominator, so I need to make sure that 330 goes in the denominator, okay? And then we're trying to figure out how many miles can be driven using 20 gallons of gas. So since we're trying to figure out the number of miles, I need x in my denominator, and then this 20 would go in my numerator, okay? So after you guys set it up, cross multiply and divide. So 15 times x is 15x, and 330 times 20, get out my calculator here, 330 times 20 is 6,600. And then to get x by itself, remember to just divide by that number attached to the x. So I'm going to divide by 15 on both sides, and I get an answer of 440. And please don't forget your label. So since we were trying to find number of miles, x would represent 440 miles. All right, moving on to the next one. Patty can make 10 purses in 8 hours. At this rate, how many purses can she make in 28 hours? So again, make sure in your proportion everything is lined up. So I see that my two variables that I have are hours and purses. Does not matter which one you put on top, just make sure that everything is lined up in your proportion. So if I put hours on top of my numerator, and our first ratio comes from Patty can make 10 purses in 8 hours, I just need to make sure that 8 goes in my numerator since that's talking about hours, and then 10 goes in my denominator since that's talking about purses. And then I'm trying to figure out how many purses can she make in 28 hours. So x will be in my denominator since I'm trying to find the number of purses she can make in 28 hours. So after you have it set up, cross multiply and divide. So 8 times x is 8x. 28 times 10 is 280. And then your last step to get x by itself is to divide by 8 on both sides. And if you take 280 divided by 8 in your calculator, you would get 35 purses. All right, moving on to our next page. Number 11, which size jar of jelly shown in the table has the lowest unit price? So if you guys remember, this was similar to the front side, number 5 down here at the bottom. So remember, to find unit rates, your operation is to divide your y divided by x. So in this case, it was the cost over the ounce. And then figure out which one was the cheapest would give us our answer. So we are going to do the same thing here. So again, to find the unit price, you are just going to divide your cost divided by your ounce. And remember, the reason why we're doing this is because if we want the unit rate, our denominator needs to be 1, and then this will tell us how much 1 ounce of these cost. and whichever one is the cheapest will tell us which one they would want to buy. So start the first one. So we have $1.69 divided by 10. Again, to find the unit price, you just divide. So 169 divided by 10, you get an answer of 0.169. But remember, we're talking about money here, so you always want to round to the nearest cent. So since 9 is bigger than 5, I'm going to round the 6 up to a 7. So this will cost 17 cents for 1 ounce of jelly. Move on to our second ratio here. So we have $3.19 for 16. So $3.19 for 16 ounces. Same thing, find the unit rate, you just divide. So $3.19 divided by 16, that gives me an answer of 0.199375. So again, always round to the nearest cent. So looking at the number behind it, I need to round this up. So since this is a 9, this now will just become 0.20 cents. So that will be 20 cents for 1 ounce. And then our last one, $5.79 for 32 ounces. Again, we're trying to find the unit rate, so we are dividing. So $5.79 divided by 32. That gives me 18 cents. So 18 cents for 1 ounce. So looking at our unit rates here, for the 10-ounce jar, it was 17 cents for 1 ounce. For the 16-ounce jar, it was 20 cents for 1 ounce of it. And then for the 32-ounce jar, it was 18 cents for 1 ounce of it. So which one has the lowest unit price? Well, it was the 10-ounce jar. So you guys can just write 10-ounce jar. All right, next one. The graph shows the savings of Rachel and Sam. What is the slope of each line? What does the slope of each line represent? This should say represent. All right, so the first thing is we need to find the slope of Sam's line and Rachel's line. So remember, to find slope, you just need 2 points on the line that cross at intersections. And then you use your rise over run formula to find the slope. And remember, you always start with the point furthest to the left. So for Sam's, I am going to use 0, 0, and 2, 20. So again, always start at the point furthest to the left, and you always want to rise before you run, okay? So notice, how far do we rise to get to our second point? And please do not say 4. Yes, there are 4 lines here, 1, 2, 3, 4, but remember, you guys have to look at your y-axis and your x-axis to see how much they're going up by. So if you guys notice, our first line would be 5, this is 10, this would be 15, and this is 20. So our lines are going up by 5s. So when you're counting up, you need to say 5, 10, 15, 20. So our rise should be 20 here. You could also tell, because notice how if we stop at this line, we went from 0 to 20. So we stopped at 20, so that means we rose 20. And then we can do the same thing for our run part. So notice how we go from 0 to 2 is our ending point, which means our run is 2. So if we rose 20 and ran 2, that means Sam's slope is 20 over 2. But remember, you guys do need to reduce that. So since 2 goes into both 20 and 2, you can reduce it by 2, and this would now turn into 10 over 1, or just 10. Okay? All right, then we'll do the same thing for Rachel's slope. So same thing, pick 2 points. So I'm going to pick 0, 0 again, and 2, 10. So again, you always want to rise before you run. So notice if I go from 0 to 10 to get from this point to this point, I rose up 10. And then when I run, once again, I go from 0 to 2, looking at my x number. So that means I ran 2. So if I rose 10 and ran 2, that means that my slope is 10 over 2. But once again, I still have to reduce that, so 10 over 2 reduces to 5. So So, next part, what does the slope of each line represent? Well, you have to look at your variables here. So our x variable was talking about months. Our y variables was talking about the number of dollars. Excuse me. And the title of this was monthly savings. So for our slope, this means for every month, Rachel saved $5. And for every month, Sam saved $10. So it's just asking what does the slope represent for both of them. So all you guys would have to say is their for every month, you could just say for every month their monthly savings, or just something along the lines of you're representing your month, so that's your x-axis, and you're representing the amount of money that they save, and then just putting it into one sentence. So I just put for every month, it talks about their monthly savings, so how much they save per month. All right, 13, a grocery store sells 6 bottles of water for $4.80 and 18 bottles of water for $22.50. Is the cost of the water proportional to the number sold? So again, a couple different ways you could do this. The way that the book taught it was to create ratios and reduce them, and if they equal each other, then they are proportional, and if they don't, then they're not proportional. So remember, money is always our top number. So if a grocery store sells 6 bottles of water for $4.80, I can write this as a ratio as $4.80 over 6 bottles. And I can do the same thing with my $22.50 for 18 bottles. And when I reduce them, if they equal each other, then they are proportional. So let's see what happens. So if I take 480 divided by 6, I get 80 cents for 1 bottle. And then if I take $22.50 divided by 18 bottles, so now I'm working on this ratio, I too, this time I get $1.25 for 1 bottle. So when we reduce these, were our unit rates proportional? No, they were not. This one cost 80 cents for 1 bottle, and this one cost $1.25 for 1 bottle. So is the cost of water proportional to the number sold? You would put no. And you guys could put because their unit rates weren't equal, or the ratio reduced were not equal, just something along the lines of about how our ratios did not equal each other and how 1 bottle did not equal each other there, okay? So that's the way that I would do that problem. Again, there's a couple different ways you could do it, but that would be probably the fastest way and the easiest way to understand that problem, okay? All right. These next ones are just solving proportions. So again, you are using cross products here. So you're just multiplying your diagonals together. So 2.5 times W is 2.5 W. 4.3 times 4 gives you 17.2. And then your last step to get W by itself is to divide by 2.5 on both sides. And then when you take 17.2 divided by 2.5, you get an answer of 6.88. All right, and then same thing over here. Multiply your diagonals. So 5 times 7.5 gives you 37.5. And then 2 times V is 2V. And then to get your variable by itself, just divide by 2 on both sides. And then 37.5 divided by 2 gives you an answer of 18.75. All right, Back page. So does this graph show a proportional relationship? So remember that there are two requirements in order for a graph to be proportional. One is it must go through origin. So in other words, 0, 0. And it must be a straight line, which means it has a constant rate of change. So we can find the slope every single time. Okay, so let's look. Does our graph go through the origin? Yep, it goes through 0, 0. And then secondly, is it a straight line? Yes, it is. So is this going to be proportional? Yep. So you will put, does the graph show a proportional relationship? Yes, because it's a straight line. That goes through the origin. So whenever you guys are explaining proportionality, you have to include both requirements in your explanation, because let's say you only put, yes, it's proportional because it goes through the origin. Well, I could give you guys an example of a graph that's not proportional, that goes through the origin, but it's not a straight line. So since it's not a straight line, then it's not proportional. Or vice versa, you guys could say, yes, it's proportional because it is a straight line. However, I could give you guys an example that is a straight line, but it doesn't go through the origin, so it's not proportional. So that's why you guys have to put both requirements in your explanation. Okay? All right, guys, last one here. So Sean and Crystal work at the hardware store. The wages earned for the weekend are shown in the table and graph. What is Sean's pay per hour, and what is Crystal's pay per hour? So first we need to find out how much Sean makes per hour. So again, a couple different ways you could do this. One way is to create your ratio. So you're taking the wage, how much he makes, divided by the number of hours. So if we were to take 20 divided by 2, 30 divided by 3, and 40 divided by 4, if you were to reduce all of these, that would give us the $10 per hour. So $10 per hour, $10 per hour, $10 per hour. Which means, how much does Sean make an hour? Well, he makes $10 an hour. Or the other way that you could do it is find your change in Y's over your change in X's. So notice that when you go from 20 to 30, you're adding 10. And 30 to 40, you're adding 10. And then looking at your X values, if you go from 2 to 3, you're adding 1. And when you go from 3 to 4, you're adding 1. So again, your slope would be your change in Y's over your change in X's. So our slope would be that 10 over 1 again. This part, what equation would represent Sean wage? So remember, our slope equation is y equals mx, where m is your slope. So if you just found out that your slope was 10, all that you guys have to do in your equation is plug in 10 for m, since m represents your slope, and then just rewrite the equation. So our equation would be y equals 10x. Now we have to do the same thing for crystals. So again, to find slope of a line, you need to pick 2 points on the line that cross at intersections. So I'm going to pick 0, 0 here, and it looks like our only other point that we could pick is this one up here. So again, to find slope of a graph, you're using your rise over your run. You always want to start with the point furthest to the left, which in this case is this point down here. And you always want to rise before you run. So notice if we rise, how far do we rise to get to our second point? And remember to be careful, because you need to look at your y numbers. You don't want to count by ones here, because notice how we go from 0 to 60, which means if you go from 0 to 60, you rose 60. And then when you're running, if you go from 0 to, this would be 5 right here. that means that you ran over 5. So if you rose 60 because you went from 0 to 60, and you ran 5 because you went from 0 to 5, this means that Crystal's wage, her slope, would be 60 over 5, which you can reduce. So when you take 60 divided by 5, you get 12 over 1. So this means that Crystal makes $12 per hour. Alright, and then since she does make 12 hours per hour, again, what equation would represent her wage? Well, our equation is y equals mx plus, not the plus b part, y equals mx, where m is your slope. So if you just found your slope to be 12, all that you guys have to do is plug in 12 for m, which means our equation would be y equals 12x. Alright, so there is one more thing that I do want to briefly talk about that could show up on your guys' test, is talking about this equation. So when we have an equation of y equals mx, this means that our graph is proportional. So as you guys notice, in Crystal's equation, the y equals 12x, notice how our graph was proportional because it started at 0, 0, and it was a straight line, okay? There is another equation that you guys will learn next year, and it adds on to this y equals mx, and that equation is y equals mx plus b. And this plus b part, so if you see a plus something or minus something in your slope equation, this is what makes it non-proportional. So just deciphering off of our two different equations. Again, your y equals mx that you guys are used to, that you guys found from your direct variation, that is going to be a proportional equation. But the slope formula, or the slope-intercept form equation, is actually y equals mx plus b. But this plus b part or minus b part would make it non-proportional. So let me give you guys a couple of examples. So if I had y equals 2x, this graph would be proportional because it does not have that plus b part, and you guys saw from up here that these look the same, they're just different slopes, okay? However, if I wrote y equals 2x plus 5, this plus 5 part is what makes it non-proportional. Okay, so anytime you guys see a plus something or minus something with an equation, that is what makes it non-proportional, because it's not going to start at the origin. So if this was the plus 5, that means that at 0, 5, that's where the graph would start at, okay? So make sure you guys have this all written down. This is a great study material for your test on Tuesday. If you guys have any questions, please reach out to your teachers so that we can help you guys. Thank you for watching.